Next, let's talk about connective tissue, the next type of tissue found in our body. Let's come back to this slide where we listed the different types of tissue. And now let's identify the different types of connective tissue that are shown on this slide. So the first type of connective tissue up here at the top is adipose tissue, or what we like to think of fondly as fat. This next one maybe was a harder one to pick out for you, but this is blood. So we have our red blood cells here, and then we have our white blood cells as well. Notice the red blood cells have no nucleus, the white blood cells do. And then down here we have cartilage, specifically hyaline cartilage. There are a few different types of cartilage. And then finally over here we have bone. These are all examples of connective tissue. A couple of things to point out that we can see here as we look at these pictures. Notice that there's space. So for example, in cartilage, these are the cells. And all around these cells, you have this whole area here that's filled in with non-living material that is not cells, but it's secreted by the cells. And that's one of the important things about connective tissue. We call this the extracellular matrix. So a few things about connective tissue. It's found everywhere in the body. It has the most abundant and the most widely distributed tissues. So I mentioned that our epithelial tissue in our skin, underneath that is a layer of connective tissue. And that's everywhere in our skin we have that layer as well. The functions, it binds body tissues together, supports the body, and helps provide protection as well. So you kind of get that out of this idea of connective tissues. It's binding everything together, holding everything together. Let's talk a little bit more about the extracellular matrix. So this is the important part of connective tissue, because when we saw epithelial tissue, we had all these cells lined up next to each other. There weren't any spaces between the cells. When we get to connective tissue, however, this extracellular matrix, let's look at the words here. Extra meaning outside the cell, and then matrix is this area. So this extracellular matrix becomes very important. We don't have as many cells in the connective tissue, but all the cells are surrounded by this extracellular matrix. So, within this extracellular matrix, we have fibers that are produced by the cells and put out into this extracellular matrix. They come in three types. We have collagen, which is white fibers, yellow fibers, elastic fibers, and reticular fibers. Different types of connective tissues will have different amounts of these different fibers depending on whether they're dense, loose, or what their function is. Also within the extracellular matrix, we have ground substance. We have, which is mainly made of water with proteins, and then also some sugar molecules that are found there as well. So let's look at some examples of connective tissue. First of all, there's something called loose connective tissue. And as we look at each of these slides, I want you to find the cells in this tissue type and then the fibers as well. So in this picture here, these are the cells. You can see the little nucleus there inside the cell. That's a drawing. And then over here, in the actual slide, these are the cells. So notice how the cells are spaced very far apart. We have all this extracellular space between them. And within this extracellular space, we have all these fibers types. In loose connective tissue, notice we have all three types. Elastic fibers, collagen fibers, very strong fibers, and the reticular fibers, though they're not pointed out here, are in there as well. So we have all the fiber types. Again, these fibers are formed by the cells. So they're secreted from these cells and packed around themselves. This is where, so when swelling happens, loose connective tissue is probably involved, because there's so much space in here that can be filled up by water. So it can soak up a lot of water and swell. We call that edema. That's loose connective tissue, specifically areolar tissue. And this is the most widely found connective tissue in the body. Another type of loose connective tissue is adipose tissue or fat. So in this case, we have our nucleus of the cell here, and then most of the cell is made up of this fat droplet. So the nucleus is pushed to the side as it fills up with this lipid molecule. Notice there's space in between here, in between the cells, that is secreted by the cells. When we think of fat, we usually think about energy storage, and that's one of the major functions of fat. But then also, insulation is another important factor. If we didn't have any fat, we'd get cold pretty quickly. In other animals, it's even more important in insulation. And then also protection. It protects the organs. So all of our organs, for example, our heart has a layer of fat around it that protects it, gives it some cushion. Reticular connective tissue, another type of loose connective tissue. Again, you can pick out the cells here. In this case, you have to find the cells versus the blood. So we have some red blood cells in here as well. And then we have the reticular cells that are creating the reticular fibers here that is found. So reticular is found in the spleen and other lymphoid organs, and so it creates this kind of framework for the spleen or the other organs, and then we have this blood running in among that framework. So we find this in the lymph nodes, the spleen, and also in the bone marrow. Okay, next we have dense connective tissue. Dense connective tissue, the main matrix fiber is going to be collagen fiber in this case. So collagen is the strongest fiber, the densest, strongest fiber, and so these connective tissues are going to be very strong and very hard. These collagen fibers are produced by the cells in the connective tissue. This is where we have tendons, ligaments. So tendons connect muscles to bones, ligaments connect bones to bones, and these are all formed by this dense connective tissue. But then also our dermis. So we have our epidermis, which is epithelial. When we're talking about the skin, we have two layers. We have the epidermis and then the dermis. The epidermis is created by epithelial cells. The dermis is connective tissue. And we'll see that in the next chapter as well. Here's a slide showing this dense connective tissue. So let's pick out the cells. So here's our cells. Our fibroblasts is the name of the type of cell that it is. And then it's producing all these fibers. Notice all these fibers in here. Very densely packed together. So if you go back to loose connective tissue, look at this areolar tissue, for example. You'll see all this empty space in here. There's a whole bunch of empty space. Dense connective tissue, no empty space. Very densely packed together, very tight. Something to point out here as well. Notice that there's no blood vessels coming through this dense connective tissue. So this is also avascular tissue. And so this is important when you think about wounding or hurting a ligament or a tendon. So if you've ever hurt a ligament, it takes a long time to heal. So if I was to give you a choice between breaking a bone and tearing a ligament, if you know about how the system works, you'd want a broken bone before you have a torn ligament, because a bone it's very vascular. There's a big blood supply, as we'll see here in a minute, and so it can heal very quickly and very completely, whereas a ligament, because of the lack of blood supply, it takes a long time to heal. Let's look at cartilage, another type of connective tissue. In cartilage, this is even more densely packed than dense connective tissue. It's a very hard substance, but not as hard as bone. And the cells here are found in spaces called lacunae. And we'll see this in bone as well. Mostly collagen fibers. And now There's a few different types of cartilage. The first one is what we call hyaline cartilage. Hyaline cartilage is the most common type of cartilage. Before you're born, as you're growing in your mother's womb, your skeletal system is first built of hyaline cartilage before any bone is ever produced. So you have this cartilage skeleton, and then on top of that cartilage, your bony skeleton starts to grow. And then we also have the larynx, which we'll see in the respiratory system, that is used in helping us talk as well. So let's look at the hyaline cartilage here. This is similar to the slide we already saw. Here are the cells. Notice they're in this kind of opening within the cartilage, and that's called the lacunae. And then we have all this fibrous material in the extracellular matrix. A couple other types of cartilage. We have elastic cartilage, and it's called that because it's elastic. So an example of this is your ear. So if you take your ear, you can bend it around. You don't want to hurt the cartilage. So similar to the dense connective tissue, there's no blood supply in the cartilage, so it heals very slowly. So if you've ever damaged cartilage, it doesn't heal very easily. And then we have fibrocartilage, and this is found in the discs in your vertebrae, in your spinal column. So if you've ever heard of slipping a disc or something like that, that's a cartilage, piece of cartilage that is found in between each of your vertebrae in your spinal column. So here's our fibrocartilage. Notice we've got our cells here, and then we've got all these fibers that are produced by the cells, and they're found in between our vertebrae there. Those are types of cartilage. Next we have bone. So bone, similar to cartilage, the cells are found in cavities called lacunae. But in this case, instead of having protein fibers, we have a calcium salt matrix. So the cells are producing these calcium salts and packing them around themselves into the extracellular matrix. We also have a lot of collagen fiber as well. So this is the most densely packed, the hardest connective tissue material that we have in the body. It has a number of functions. It protects the body, supports the body. And then something you may not think about, but an important function of the bone, is it's a storage deposit for minerals that we need, such as calcium, magnesium, and things like that. So the bone is very important. And then we have two types of bone. We have what's called compact bone, and we have spongy bone. We'll talk more about what those are when we talk about the skeletal system. But in this slide I'm going to show you here, this is showing compact bone. Compact bone is found in the outside edges of the bone and in the ends of the bones. And we have these things called osteones, which are these circular type parts of the bone. And within these osteones we have these little lacunae, these spaces. That's where the cells are sitting. Then all around themselves they pack all this calcium salt and collagen fibers. We have this space here. This is called the central canal, and up the central canal, this is where the blood and the nerves come. So notice that each of these osteones has a central canal where the blood is coming up. And so the bone is inundated with blood. There's lots of blood here, lots of nourishment. We often like to think of our bones as being static. They don't change, but bones are always changing. We're building bones, we're breaking down bones. And as if we actually fracture a bone, it can be healed very quickly because of all this blood supply that's there. So that's the bones. Okay, next we have blood. And as we've been talking about connective tissue, we've been talking about the extracellular matrix and this idea of fibers. And so when you look at blood, initially you may say, well, where are the fibers? The cells are obviously here. So we have our red blood cells, our white blood cells, and we have this extracellular matrix, this fluid matrix that they're floating in. But there are fibers in blood, they're just not readily visible. But if you've ever cut yourself and your blood starts to clot, that's because fibers start to appear. So the building blocks of the fibers are always present, but not until they're triggered to start doing the clotting process do they become visible. So there are fibers in this connective tissue. But it's also connective tissue because it connects all of the body. It brings nutrients and oxygen to all the different parts of the body. Those are the different types of connective tissue.